When did humanity shrink to just a few souls? What crisis almost erased our species? How did just 1,000 survivors rebuild all civilization, twice? When did the world stand on the brink of extinction? What triggered the bottleneck that reshaped us? How did a few ancestors spark the human race again? Let's start. Humanity's deepest crisis occurred tens of thousands of years ago. Genetic evidence points to dramatic, population bottlenecks, moments where our numbers plummeted to a few thousand reproductive individuals. The most dramatic may have occurred during the Toba supereruption around 74,000 years ago, when a volcanic winter plunged global temperatures and devastated ecosystems. Researchers estimate only 1,000 to 10,000 people survived, and perhaps closer to 1,000 breeding individuals. These survivors' descendants repopulate the world, but with altered genetic diversity. Anthropologists use the term effective population size to describe how many genes carried forward. Studies in modern human DNA, mitochondrial lines and Y chromosome markers, reveal consistent signs of this genetic bottleneck. Evidence comes not just from Toba. Other climate crises, ice ages, and regional catastrophes contributed to repeated population stress. It's within these near disasters that our species' story pivots. It's important to note, these survivors weren't clustered in modern nations. They likely lived in small bands across East Africa, perhaps sheltered by microclimates around Rift Valley lakes. They spoke early proto-languages, used stone tools, and carried cultural memory across millennia. This is not mythology, it's genetics, archaeology, and paleoclimate science converging. The world teetered on extinction, then humans rose again. In Sumatra lies Lake Toba, the remnant of a supervolcanic caldera that erupted with unimaginable force. Scientists estimate the eruption released 2,800 cubic kilometers of material, ejecting ash into the stratosphere and blocking sunlight for years. This triggered a volcanic winter, which may have reduced global temperatures by as much as 3 to 5 degrees Celsius for a decade or more. That deserves urgency. Human groups reliant on plant and animal resources would suddenly face collapse. Excavated sediment cores and paleoclimate reconstruction support this modeling. Evidence shows synchronous ash layers and dramatic temperature shifts globally. Geneticists observe a sharp reduction in genetic diversity across all human populations that time-aligned with Toba's eruption. The scale of devastation, crop failures, hunted megafauna disappearing, social network breakdowns, could have forced extinction, if not for isolated pockets of resilience. Localized communities, perhaps near equatorial lakes or refugial ecosystems, kept life ticking. They became genetic wells from which modern humanity sprang. These were not tens of thousands, they were thousands. Writers and filmmakers often dramatize this. Imagine a family group huddled before simmering lava curtains, banding together to survive the longest winter humans had ever known. That trauma would echo through DNA, and through myth. Geneticists use mitochondrial Eve and Y chromosome atom terminology, not to denote individuals, but the most recent common ancestors of all living humans via maternal and paternal lines. These aren't biblical figures, they're statistical signatures. Genetics shows a bottleneck of effective population size around 1,000 individuals roughly 70 to 100,000 years ago. This bottleneck is consistent across all continents, even early out-of-Africa migrants. Scientists have calculated that today's humans share roughly 99.9% DNA similarity, but the remaining 0.1% includes the population history encoded in single nucleotide polymorphisms, SNPs. Mutations trace back to those survivors. Ancient genome studies, including Neanderthal admixture, show we all descend from these survivors, with minor interbreeding events. Yet the core gene pool stems from that bottleneck. Paleoanthropology confirms human continuity in East Africa from 200,000 years ago. Fossils like Homo kaibish, Herto, and Jebel Irhoud show anatomically modern humans, but genetic methods show only small founder populations moving outward. So while our species existed, our numbers were dangerously low. This doesn't diminish our origins, it highlights them. Humanity kept burning, despite near extinction. How did these human pockets persist? Survival hinged on cooperation, creativity, and adaptability. Bands formed stable social networks, sharing food, knowledge, and bloodlines. Tool technologies improved, microliths, blades, harpoons, they enabled efficient hunting and gathering. Symbolic behavior, beads, ochre painting, likely helped maintain group identity during crisis. These survival tools were as crucial as fire or shelter. Ecologists argue that proximal rich resources, like Rift Valley lakes, riverine forests, and coastal ecosystems, became refugia. These pockets provided stable food supply and moderate climate buffers. Genetic and linguistic homogeneity in those regions supports long-term human occupation and small group cohesion. Cultural memory, passed orally, carried lessons learned through collapse and recovery. Researchers also highlight low mortality rates due to cooperation, sharing wounded or aging individuals, rotating leadership, and egalitarian structures that reduced conflict. Anthropologists see parallels in modern hunter-gatherer groups like the Hadza or San, where survival depends on group consensus and resource sharing. Ancient humans may have modeled similar behavior. Between 60,000 to 50,000 years ago, survivors began expanding out of Africa, into Eurasia, Australia, and ultimately the Americas. This out-of-Africa migration carried small founder populations, often just a few dozen individuals per wave. Still, they carried the same genetic legacy from the bottleneck, which spreads globally today. Travel across ecological corridors, coastal routes, river valleys, and mountain passes, enabled gradual dispersal. Even as modern humans met Neanderthals and Denisovans, admixture added small genetic contributions, but the core gene pool remained from the bottleneck survivors. Linguistic and archaeological patterns align. Stone tools, blades, art, and burials spread swiftly, indicating cultural as well as genetic diffusion. This expansion wasn't linear or guaranteed. Climate shifts, sea level rises, and megafauna extinction presented challenges. But the ability to innovate shelters, tents, clothing, animal hides, and technology, boats, fishing gear, sustained continued dispersal. By 10,000 years ago, Homo sapiens occupied virtually all continents, from Siberia to Tasmania, from Europe to the Americas. That bottleneck group's genetic legacy laid groundwork for all future civilization. Whatever traits survived, adaptability, social cohesion, learning across generations, came from those survivors. Many neuroscientific and behavioral genes linked to cooperation and cognitive flexibility may trace to this era. Civilization rests on a genetic foundation shaped under stress. Gene variants influencing digestion, lactase persistence, disease resistance, HLA genes, and brain development, FOXP2 variants for language, all emerged or spread after the bottleneck. Agriculturalism allowed dramatic population rebounds, but the underlying human biology from those survivors enabled this transformation. It's not romantic to say, we owe civilization to those few fringe bands. Moreover, as groups split and diversified into Mesolithic, Neolithic, Bronze Age cultures, traditions like storytelling, inheritance, trade, and social hierarchy all owe roots to foundational human social structure from bottleneck survivors. The first villages, trade routes, and religious rituals emerged from small cooperative clans who already had deep survival learnings from extinction. That ancient bottleneck offers lessons today. Genetic diversity is vital. Homogeneity increases vulnerability to disease or environmental shift. Modern populations sometimes face genetic drift in isolated communities. The past teaches interconnectedness and gene flow enrich resilience. Humanity today faces global catastrophes, climate change, pandemics, nuclear risk. Our ancestor bottleneck shows survival is possible if groups cooperate, share knowledge, and adapt culture quickly. But it also warns that small disruptions, ecological collapse, governance breakdown, can cascade rapidly. Meanwhile, de-extinction and synthetic biology raise ethical questions. If we engineered new human-like beings from limited cells, would they face their own bottlenecks? The paradox of limited founders endures. Our survival strategy must innovate, variant diets, varied habitats, and genetic stewardship. We started with thousands at the brink. Today, 8 billion walk this planet. Every one of us carries a fragment of that ancient bottleneck. Civilizations rose and fell, but humanity persisted, and amplified. This isn't just ancient history, it's a story of resilience and caution. It reminds us, survival matters more than size, cooperation more than conflict, and diversity more than homogeneity. The next crises, climate, biothreats, AI, may challenge our species again. But if we learn our history, the answer lies not just in population growth, but unity in diversity. Ultimately, human civilization is an echo of a few thousand souls who refused to disappear. They rebuilt our world. Now, the question shifts, will we honor them, or repeat their near fall?